Good morning to all. We are discussing the finite automata, that is non-deterministic finite automata, and the conversion of non-deterministic finite automata, that is NFA with epsilon moves to NFA without epsilon moves. And in the previous lecture, we have discussed how to convert this NFA with epsilon moves to the NFA without epsilon moves, right? So in this lecture, what we are going to discuss is nothing but conversion. The next part, the conversion of NFA. So you know that to convert NFA with epsilon moves, there is a method, there is a formula. We have used a particular formula and we converted the NFA with epsilon moves to NFA without epsilon moves. And finally, our ultimate goal is we want to convert that particular NFA to the DFA, that is nothing but your deterministic finite automata. So these three are the main important conversions that we need to understand. Conversion of NFA with epsilon moves to the NFA without epsilon moves, right? So this one is already we have discussed. Then the very second, second important point is nothing but how to convert NFA without epsilon moves to DFA. See here, now we are directly moving towards the DFA, means we have to convert the NFA into the DFA. So you know that the DFA, it may have the epsilon moves or without epsilon moves. So without epsilon moves, so we have to consider first NFA without epsilon moves, means we have to convert your plain NFA, we have to convert this plain NFA into deterministic finite automata, that is NFA into DFA conversion. And the lastly, finally, we have to convert, or we have to see the study the NFA with epsilon moves to DFA, right? So these are the three important conversions that we must understand it. So in this today's lecture, we are going to focus on conversion of NFA without epsilon moves to NFA, sorry, DFA. So without epsilon moves, NFA means it is nothing but just your simple NFA, or you can say that it is just a plain NFA, that is a simple non-deterministic finite automata. So NFA to DFA conversion we are going to study in the today's lecture, right? So let us see the methodology. Conversion of NFA without epsilon moves to DFA, right? So an NFA without epsilon moves can be converted to equivalent DFA. NFA without epsilon moves is given by, see here, that is NFA without epsilon moves is given with the help of this particular, you know that NFA, definition of NFA and the definition of DFA. So in the earlier lecture or in the previous conversion, what we have discussed, we have discussed NFA with epsilon moves to NFA without epsilon moves, right? So in that particular case, both the automata are NFA, means we are not going to change the type of automata, we are not going to change the type of that finite automata in both the cases. Means in previous case, means in the question also we have NFA, in answer also we are getting the NFA, but here in this case, the in question we have NFA, that NFA means it is with without epsilon moves, that NFA without epsilon moves, but this NFA must be converted into DFA, that is nothing but deterministic finite automata. And you know that in case of deterministic finite automata, there must be a single transition, or on a single input there must be only finite number of states, or there must be deterministic number of state is possible. For example, if Q0 is there, so Q0 on 0, it must go to Q1, and Q0 on 1 go to Q2. There should not be two transition on same input symbol in case of DFA, right? So what we have to do here, we have to convert our NFA. This is the case of your NFA. Now this NFA need to be converted into the deterministic finite automata, that is nothing but your DFA, right? So NFA without epsilon moves machine, it is described with the help of Q sigma delta Q0 capital F, where Q is nothing but the finite set of states, sigma is nothing but a finite set of input alphabet, delta is the transition function in NFA, Q0 is nothing but the start state, capital F is nothing but the final state. And the transition function described like this: delta is nothing but Q into sigma, that is gives equal to 2 raised to Q, means current state into input symbol, that gives you the next state or the new state, right? This is the case of your NFA. So here now we are not calling it as a NFA without epsilon moves in this lecture, we are just referring it as a NFA, means simple in simple word we can say that we have to convert the NFA into DFA. And the DFA is now defined with the help of this particular tuple, that is Q dash, that is M dash, that is equal to Q dash input sigma delta dash Q0 dash F dash. See here, so Q dash is nothing but the finite set of states. Sigma is nothing but again input alphabet. Delta dash is nothing but the transition. Q dash is nothing but the start state, and F dash is nothing but your set of final states. And here the function, transition function, is defined like this: Q into sigma, that gives you the next state, right? So where is the difference? You will find the difference is here. So here Q into sigma, that gives you number of next states, the next state in the power of 2. But here Q into sigma, you will just get a single next state, only one next state or the new state from current state. Getting this point? So the see here difference. So Q, so in case of your NFA, you have capital Q means set of state. That set of state is now converted into the Q dash. In case of your NFA, you have the delta. Now this delta, it is converted into the delta dash transition. In case of NFA, you have Q0. That Q0, it is now converted into the Q dash. Means there is a change. Dash means it indicates the changes in which parameter the changes occur while converting the NFA into DFA. So these are the parameters. Q dash means definitely there is a changes in the set of states. Then delta dash, definitely there is a transition function changes. In this particular case, you have this transition function. In case of DFA, you have to find out, for DFA, we have to find out this delta dash transition function, right? Also, we have to find out the start state, that is Q0 dash, and also we have to find out the F dash, means which are the different final states, means it is nothing but the set of final state that we have to find out. So which thing remains constant here? Only the parameter which does not change is nothing but your input alphabet, sigma. See here, sigma, it is indicated or it is named as a sigma. In case of NFA, the same sigma you are indicating here, sigma, it is not a sigma dash, it is not there, right? So meaning is that we have to, while converting our NFA to DFA, these parameters are to be changed. Means in case of original given NFA, you have Q, but while finding out the DFA, in the resultant DFA, we'll get here Q dash. In case of your original NFA, we have delta transition, but we have to find out this delta dash transition. In the original NFA, we have Q0, that is nothing but the start state, but here we have to find out the Q0 dash. Final state in the NFA, it is now converted into the F dash instead of final states that we have to find out for DFA, right? Thus, and only parameter remains change is nothing but your input alphabet. Input alphabet is not going to be changed here. Say for example, 0, 1 is the input alphabet. The same will be remains here. You are not going to increase or decrease number of input alphabet, right? So, or if it is a comma B, so you can have A and B, same input set will be in DFA as similar to the NFA, right? So the start state of NFA will be the start for a DFA. Hence, the Q0 of NFA to Q dash. So we'll just put this Q0 into the Q dash. Then find transition from this start state. So see here, while converting NFA to DFA, what we have to see here, we have to always start with the Q0 state which is given in the question. Suppose a NFA is given, NFA it starts with the Q0 starting state. So starting from that start state, we have to find the transitions. We have to find the transition. And which transitions? We have to find this delta dash transition, this delta dash transition we have to find out, so that we can able to convert step by step NFA to DFA, right? Okay, the next step, see the next point here. For each state, see here, for each state Q1, Q2, Q3, up to Qi in Q dash means in DFA, the transitions for each input symbol sigma can be obtained as, see here, delta dash. So how to find out the transitions for DFA? So for DFA, transitions can be find out with the help of this delta dash. So Q1, Q2, Q3 up to Qi comma A, where A is nothing but your input delta Q1A. So you are going to split with the help of union symbol, Q1A union delta Q2A union delta Q3A whatever it may be. You are getting here some transitions, q1a go to q1, for example, q2a go to q2, or q3a go to q3 up to qk. And if you get here new state generated, if the new state is being generated here, if it is generated, if you able to generate the new state, then again you have to find out the input, the transitions on input symbol for newly generated state. Right, means new state means what? The state which is not exist in current nfa. New state means what? The state which is not exist in current nfa, the newly generated state is there. So for that newly generated state, we have to find out the transitions on both input symbol, that is a and b. So here add this new state, that is q1 q2 up to qk to dfa. If it is not already added in q dash, means we are now changing this q dash set of states, right? In case of our nfa we have q, but now we are changing it to q dash. Then find the transitions for every input symbol from sigma for each newly generated state. If we get some new state, that is q1 q2 dot 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 qn, again if we are finding some new state which is not in q dash, which is not in the set of states of dfa, then add this state to q dash state, right? So if there is no new state is generating, then stop the process after finding all transitions. Means we have to start with our start symbol, that is q0, and find out their transitions with the help of this delta dash q1 q2 whatever it may be the state, and we have to take all input, that is a b, or suppose there are inputs like 0 1 2, consider this input, take their transitions with the help of and make the union of this, and you will find some state here. But if this state is already present, then there is no question. But if this state is not present, then mark this as a new state. And for this newly generated state, again you have to find out the transitions for both the input or whatever may be the number of inputs are there, right? And add this particular state into the set of states, that is q dash. For state q1 q2 of dot 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 up to qn in q dash of dfa, if any one state qi is final state of nfa, then q1 q2 dot dot qn becomes the final state. So it may happen that, for example, if q0 q1 q2, if these three are the states, and if the q2 is the final state in case of our nfa, q2 is the final state in case of our original nfa or the given nfa, and if suppose new state generated like this q0 q2, so mark this q0 q2 as a final state also. So meaning of this particular statement, for a state q1 q2 dot dot qn in q dash of dfa, so q dash we are finding for dfa, that is resultant dfa. If any one state qi is a final state, suppose for example here is a qi is a final state, then this entire state becomes the final state in dfa. Then this entire state becomes the, because it comes with q0, or suppose there may be suppose a new state generated like this q1 and q2, but q2 in case of nfa, it is a final state. So q1 q2 you mark it as a final state in your dfa. Getting this point? So we'll see the example. So let us see here. So start with an example. Convert the given NFA to its equivalent DFA. Convert the given NFA to its equivalent DFA. So NFA diagram is given here. So very first step is the transition table. You have to write down the transition table for the given NFA diagram. The transition diagram of NFA is given. So first step is to draw. So NFA given. So Q0 on 0 go to Q0. So see here Q0 on 0 go to Q0. Whereas Q0 on 0 go to Q1 also, because it is NFA, you know that, and multiple transitions are possible in case of NFA. And Q0 on 1 go to Q1 only, but whereas Q1 on 0, it does not go to any state, that's why it is marked as a phi. Whereas Q1 on 1 input, it go to Q0 as well as Q1, right? So in case of so the NFA given in the transition in the diagram, we need to convert this NFA into the transition table. So first we have to write down the transition table for the given NFA. This is the first step, right? And here you can write, so Q1 is marked as a star, that's because it is nothing but your final state. Q1 is marked as a star in the transition table because it is a final state. and this arrow means it is nothing but your start state. So start state, you know that start state is always marked with the arrow, whereas the final state is marked with your star symbol. This is the point. Next point. So see here carefully, from the above table it is clear that there are q0, q1 and q0, q1 states for its equivalent DFA, right? So from this particular transition table you can observe the transition table and you can write a statement like, yes, how many states are possible? So there are states, q0 is one state, q1 is one state, no doubt, because from the diagram it is visible to you, q0 and q1. The states in NFA, equivalent state will be in DFA. Suppose if I need to convert this NFA, suppose this NFA to DFA, so first I have to, so this is q and here I have to find out the q dash. So here q0 is there, so definitely q0 will be there in DFA, then q1 will be there in DFA, but one new state you will find here from the transition table, that is called as q0, q1. Combiningly it is a new state. So you can have q0 is one state, q1 is another state, and q0, q1. So you can mark a bracket, opening and curly bracket, and you can include this q0, q1 inside that particular curly bracket, and this becomes your third state. This becomes your third state. So this is the first state, this is your second state, and this becomes your third state. Getting this point? So we are getting third state for our resultant DFA, right? The first step. Now what is the second step? Now once you get the third step for the resultant DFA, we need to find out their delta dash transition for this third state on input A, on input 0 and input 1, because there are two inputs, 0 and 1. So we need to find out the transitions on input 0, on input 1. So we need to compute the transition from state q0, q1. So see here it is written in the bracket for each input symbol 0 and 1. Getting this point? So see, once again, see it carefully, how to convert the given NFA to its equivalent DFA. So NFA diagram is given. So very first step, remember the first step, do not get confused, do not get jumble here. So first draw the transition table. Now from transition table you can find that, yes, how many states are there? There are state q0, q1, which are already, it can be visible from your diagram, but there is a state q0, q1 combiningly, which is not, you can see from this diagram, but it can be observed from the TT, that is transition table, for its equivalent DFA. Now once you find out the new state, we have to compute the transitions from this particular state q0, q1 for each input symbol, that is 0 and 1, right? The next point. See here, step number 2. Hence, compute a delta dash transitions. Compute delta dash transition for each input 0 and 1 for the state delta dash into bracket q0 comma q1 comma 0, right? So see here. See here. So new state generated is nothing but q0, q1. So this is the state. So see carefully how to write the state. You have to give the square bracket, opening square bracket and closing square bracket. This bracket also has some important feature here, or they are having some significant value. So in square bracket, meaning is that you are having your DFA. If it is in a square bracket, you can find it is in a DFA, right? So in q0 comma q1 comma 0, this is the input symbol, this is your state. So you split it, you know that how to split. So delta q0 on 0, so you have to take the true transition delta q0 on 0 and q1 on 0 and make union of it. So delta q0 on 0, delta q1 on 0. So delta means transition from q0 on input 0. The answer is q0, q1 again, because from the transition table you can find that q0 on 0 go to q0, q1 again, and q1 on 0 there is a transition on q1 itself. So there is a union of q0, q1 union q1. So result is q0, q1, but this is already available. q0, q1 is not a new state, the state is already available with us, right? So there is no question. Then delta dash q0, q1, take another input that is equal to 1, split it q0 on 1 and q1 on 1. So you will find here q0 on 1, there is no transition, that's why it is marked as a phi. So this is the answer for this. And q1 on 1, is nothing but Q0, Q1. So what is the answer? Q0, Q1, and the state is already available with us. This particular state is already available with us. So the conclusion is written here. No new state is generated. The first point. In given NFA, Q is the final state. So sorry, in given NFA, Q1 is the final state. Hence, in resultant NFA, wherever Q1 exists, wherever this Q1 exists, all that states become the final state. So Q1 is the final state. So Q0, Q1 definitely becomes your final state. So wherever there is appearance of Q1 is there, you will find Q1. So make it as a final state. Getting this point? Because in NFA, given NFA, Q1 is final. So in case of resultant DFA, wherever appearance of Q1 you will find, you mark it as a final state, right? So all the transitions are over, and now see, hence the transition table for the equivalent DFA. So how to draw the transition table, and while writing the transition table for the DFA, so take a you have to take care that all the state you have to write in a square bracket, and square bracket indicates your DFA, whereas curly brackets indicates your NFA, states in NFA, and the states in DFA means it is not a rule, but it is just a thumb rule, or it is just for our understanding purpose, or for our convenient, we are writing this. Suppose if a state is written in like this, so we can call it as a state in a DFA. But if the state Q0 is written like this, so it is in a NFA. NFA. Getting this point? So Q0, Q0, Q1, these two lines or these two rows are same as per the given NFA. There will be no change. If you find here, so Q0 on 0 go to Q0, Q1, Q0 on 1 go to Q1, Q1 on 0 go to 5, and there is no transition, and Q1 on 1 go to Q0, Q1, means these two rows, they are similar as that of given in the question, or as that of we have drawn earlier, right? Only the transitions we have find out, that is Q0, Q1 on 0 input, that goes to next state is Q0, Q1, and Q0, Q1, this is the state, and 1 is the input, it again goes to Q0, Q1, right? And wherever you will find the, so Q1 is the final state in your given NFA. So in case of DFA, in case of resultant DFA, wherever you find this Q1, you mark it as a final state. That's why this state is also marked as a final state, right? So first step, we have find out the new states, and for all the new states, if the new state is generated, we have find out their delta dash transitions, and for these delta dash transitions, or if all the transitions are finished, if the no new state is being generated, then we draw the transition table. We draw the transition table for the equivalent DFA, right? The next point, and this is the resultant DFA, or this is the transition diagram for the resultant DFA. That is nothing but it is the converted DFA. So see carefully, the Q0 is here, so Q0 is marked as it is. Q1, it is the final state, that's why marked in a double circle, right? And one new state is generated, which is then that new state. That new state is nothing but Q0 comma Q1, Q0 comma Q1, and that state is marked as a final state. That's why it is marked in a double circle. You know that the final state is always marked in a double circle, and put these states in a, say for example, square bracket, and the transition Q0 on 0 go to Q0, Q1. This is the state. Q0 on 0 go to Q0, Q1. This is the state. And Q0 on 1 go to Q1. Q0 on 1 go to Q1. Q1 on 1 go to Q0, Q1, but there is no transition on 0 input from Q1 symbol. But Q0, Q1 on both 0 as well as 1, it is a self loop, or it is a self transition. So this is nothing but your resultant DFA. Now you check here, deterministic finite automata means there is only a single transition on a single input symbol to a defined state or to a determined state. See, Q0 on 0, only one transition. Q0 on 1, only one single transition. Q1 on 1, there is a single transition, and Q1 on 0, there is no transition. Whereas Q0, Q1, only single transitions on 0 and 1. That is nothing but our DFA is correct. This is how we have drawn the corrected deterministic finite automata, right? So see the NFA. So see the earlier figure of our NFA. This is our non-deterministic automata, right? And this NFA, it is now converted step by step into the resultant DFA, that is deterministic finite automata, right? So see, this is your DFA. The next step, we can change the names of the states. So what is happening here, putting this q0 q1 into the square bracket and making it a circle, this becomes a very tedious task. So you can change the all the states names to A, B, C, capital A, capital B, and capital C. So I can mark here capital A equal to q0, capital B equal to q1, and q0 q1 I mark it as a C, and rest of all the transitions remains same. So final DFA I can draw like this. So it becomes the comfortable to draw and easier to understand as compared to this one, right? So this is our final answer of DFA, that is A, capital A goes to capital B, capital A on 0 goes to capital C. Getting this point? Okay, so let us go to the next example. Convert the given NFA to its equivalent DFA. Now this NFA is given in the diagram. Q0 on 0 goes to Q0 Q1, Q0 on 1 goes to Q0 itself. Now Q1, so first we have to draw the transition table. As you know that the very first step to draw the transition table, from the transition table it is clear that we can find out easily where is exactly the transition and which are the new states. So here the Q0 state, so in case of, if I want to draw the resultant DFA, in case of DFA, how many states will be there? So there will be Q0 as a start state, then Q1 will be there, Q2 will be there, Q3 will be there, and as the Q3 is the final state, wherever may be the appearance of Q3, all the states, all that particular state becomes your final state. And one more new states I find here, that is nothing but your Q0 Q1. So in my DFA, in my resultant DFA, I will have this Q0 Q1 state, right? So all the transitions, so transitions of all these states I have all with me. Transition on Q0, transitions of Q1, Q2, and Q3, I have all these three with me. But suppose, so I have to find out Q0 Q1 transitions, so where it goes. So Q0 Q1 on one input where it goes, and Q0 Q1 on one 0 input and 1 input where it goes, that I have to find out. Means it is a very simple logic. So see here, so from the above table it is clear that there are Q0 Q1 Q2 Q3, these are the state, and Q0 Q1 are the states for its equivalent DFA, so we need to compute the transitions from the state Q0 Q1 for each input symbol 0 1. Okay, so let us see, let us start calculating this. Step number 2, hence compute delta dash transition for each input 0 and 1 for the state. So delta dash Q0 comma Q1 in a square bracket comma 0, that is equal to delta, split it Q0 comma 0 union delta Q1 comma 0, that is equal to Q0 Q1. So answer for this Q0 on 0, Q0 on 0 is goes to Q0 Q1 union as it is union, and delta Q0 on 1 go to Q2 state. So see here Q0 Q1 Q2, you are making union, so you are getting here new state, that is nothing but your Q0 Q1 Q2 combiningly. So combiningly Q0 Q1 Q2, these are not three states, these are the combined, it is only a single state, it is only single state, that is called as a new state, and this new state is generated. So again we have to find out the delta dash transition for this newly generated state on input 0 and 1. Getting this point? So just mark here, it is a new state generated. Now 1 point is remaining here, that is nothing but our 0 is completed. 0 is completed here, we have to find out for 1 as input. So take this delta dash Q0 comma Q1 on 1 input, that is equal to delta Q0 on 1 union delta Q1 on 1, that is equal to Q0 union Q1, that is equal to Q0 Q1, and this state is already available, it is not a newly generated state, this state is already here, and we already calculated the transitions on both the input for the Q0 Q1 state. So I have written here no new state is generated. So again compute the delta dash transition for each input 0 and 1 for the newly generated state, that is Q0 Q1 and Q2. Okay, so the next line, delta dash into square bracket Q0 Q1 Q2 comma 0. So take the first input, this is the newly generated state here you are taking, and this is nothing but your input symbol first 0, split it delta Q0 comma 0 union delta Q1 comma 0 union delta Q2 comma 0 means these all are nothing but the transitions. So write down their answers and you are making just union of this. Okay, so in the next line, it's nothing but your Q0, Q1 union Q2 union Q3. So finally, I'm getting again another new state that is nothing but Q0, Q1, Q2, Q3. Again, one new state is being generated here because which is not available in the given NFA. We are generating or the new state is getting generated here. That's why it is marked as a new state. And for this state also on 0, comma 1, we have to find out the delta dash transitions, right? So one by one, step by step, we are going to solve this. The remaining is one input. So take the state Q0, Q1, Q2 on input 1 and bifurcate it or split it Q0 on 1, Q1 on 1, Q2 on transitions of Q2 on 1. Make a union of these three Q0, union Q1, union Q3. So you are getting Q0, Q1, Q3. So this state is also not available. See here Q0, Q1, Q3 is not available. Which is the available? Q0, Q1, Q2 is available, but this state is not available. Q0, Q1, Q3. That's why it is called as a new state. So how many new states are generated here? Two new states are generated. This is one and this is another. So two new states are generated. So how many transitions are remaining? So four transitions. For this, we have to take 0 on 1. For this particular state, again, we have to check for 0 and 1 transitions, right? So let us solve it step by step. So take the first one. So two new states are generated, that is Q0, Q1, Q2, Q3 and Q0, Q1, Q3. So compute a delta dash transitions on each input for these new states, right? So how to calculate it? The method is same. There is no difficulty. There is no any we can say no any critical part. Everything is very simple. But only the thing is that you have to go step by step, follow each and every step. So take this state Q0, Q1, Q2 on 0 transition. 0 transition means you have to split it. Delta Q0 on 0, delta Q1 on 0, delta Q2 on 0, delta Q3 on 0, and you have to take the union of all these. So Q0 on 0 is nothing but Q0, Q1. Q1 on 0 is nothing but your Q2. Q2 on 0 is Q3. And Q3 on 0, no transition. That's why I'm marked as a phi. So you are getting here Q0, Q1, Q2, Q3. It is not a new state because this state is already available. Because this state is already we have found out and we are finding their transitions on 0 and 1. Now Q0, Q1, Q2, Q3 on one input and the transitions are here we are getting Q0, Q1, Q2, Q3, the same state, no new state is being generated, right? So the two transitions on these two inputs are over for this state. Now only one state is remaining for the transition to find out the transitions, that is nothing but your delta dash transitions for state Q0, Q1 and Q3. So take this, find out their transitions. So here we are getting Q0, Q1, Q2 as the answer, but this Q0, Q1, Q2 already we have find it out the transitions on 0 and 1 input. So that's why you mark it as a no new state is being generated. And same for delta dash transitions Q0, Q1, Q3 on input 1, that is equal to delta Q0, 1, again delta Q1, 1 and delta Q3, 1. So Q1, Q0, Q1, Q2, that is nothing but your Q0, Q1, Q2. Again, a same state, that is a no new state is being generated, right? So here we are stopped, means here we cannot proceed further because no new state is being generated. So finally, we can write like this. So hence the transition table. So first step is to write down the transition table for the resultant DFA, and the transition table is like this. Okay, so up to this, so I can have up to this already. You have to just copy it from the given NFA. This all this value, because Q0, Q1, Q2, Q3, all these rows are you have to copy from the given NFA. So which values you have find out? We have find out here Q0, Q1 on 0, Q0, Q1 on 1, Q0, Q1, Q2 on 0 and 1 input, Q0, Q1, Q3 on 0 and 1 input, and Q0, Q1, Q2, Q3 on 0 and 1 input. These four values means 4 plus 4, 8 transitions we have find out just now. That's why we have written in the transition table. This is the now the next point is that Q3. Now Q3 being the final state in the NFA, it is marked as a mark with the star signature, star sign. That's why wherever there is appearance of Q3, you mark this state as a final state. Getting my point or not? Q3 it is marked, it is given as a final state in the given NFA. So wherever there is appearance of Q3, so you just mark it as a total state. So remember, write the state in a square bracket for the resultant DFA. So this entire state now becomes your final state. This entire state now becomes your final state. So this is your final state. So how many final states are there? Yes, Q3 is one final state. Q0, Q1, Q3 is another final state, and Q0, Q1, Q2, Q3 is the final state. That's why this F dash is nothing but the set of states. It is nothing but your set of state. That is nothing but your Q3. Then it contains Q0, Q1, Q3. This another state, and next is nothing but Q0, Q1, Q2, Q3. Three states are the final states here, right? So draw the transition diagram. From this transition table, it is easy to draw the transition diagram. See here, Q0 on 0, go to Q0, Q1. Then we have to always see here, we have to always start with the start state. And which is the start state? The start state is Q0. It goes to Q0, Q1. Then it go to then Q0, Q1. So Q0, Q1 on 0 go to Q0, Q1, Q2. This is the state. And again one go to Q0, Q1. Again one go to Q. So self transition. Then Q0, Q1, Q2. From the diagram, it on 0 go to this particular state. That means here, and 1 it go to Q0, Q1, Q2 on one transition, right? And all the rest of the transitions you have to mark here. So remaining transitions, so there are few transitions are remaining. See here, Q1 on 0 go to Q2, and Q2 on 0 and 1 go to Q3. But here we are not going to include this particular part because it is not being connected anywhere with our DFA. This part will be excluded. This part will be excluded from our resultant DFA because there is no connection from there is no connection means there is no transition from start state or from any other state to either Q1, Q2 or Q3. That's why this particular portion is now excluded. It is not included in the final DFA. So final DFA, just convert, just name this capital A, capital B, capital C, capital D, and capital E. Just name it and just draw the transition, and you will get here the resultant deterministic finite automata. Getting this point? So just remember the point that the state, as these state, they do not have any connection or they do not have any connectivity. They do not have any connectivity with any of the state in the given DFA, and this is the separate. This portion becomes the separate. So no need to draw inside that particular DFA. No need to draw any transition because it is not given. So it is totally excluded, and the resultant DFA with the revised nomenclature, that is capital A, capital B, capital C, capital D, and capital E. The transitions are same. So A on 0 go to B, capital A on 1 go to A only. So only single transition on a same input symbol. B on 0, B on 1, C on 1, C on 0, D on 0 goes to C, and D on 1 goes to C, E on 0 and 1 goes to E itself, right? So this is your final deterministic finite automata. Getting this point? Okay. So let us check with another example. See, one more NFA is given. The diagram is given. Non-deterministic finite automata is given Q0. And first step, you know that what is the first step? First step is to write the transition table for the given NFA, and the transition table from the transition diagram, it is written here. Now I have written with the help of pen, right? So Q0 on 0 go to Q0 Q1, Q0 on 1 goes to Q0 Q3. So already I have told you that while writing the states in NFA, always write in a curly brackets. You have to give the curly bracket. It is just a significance. NFA states are written in the curly bracket, whereas in case of DFA, while writing the DFA, now these states are written like this: Q0, Q1 in the square bracket. Just for your understanding. So all the transitions are drawn in the transition table from this transition diagram of NFA. Okay, transition table. And there are two final states. Q2 is the final state and Q4 is the final state. They are marked here. Q2 is the final and Q4 is the final state. These are the 5 transitions, means there is no transitions, only the transition. So from transition table, what we have to find here? We have to find out the new state. So in the resultant DFA, in our DFA, this Q0, Q1, Q2, Q3, Q4, they will be there as it is. There is no question. They will be there as it is. But which are the additional states? There are additional states. These are the two additional states, Q0, Q1 and Q0, Q3. These are the new states whose transitions that we have to find it out, right? On both the inputs, that is nothing but 0 and 1. So start finding out this. Step number 2, from the transition table, we get two new states, that is Q0, Q1 and Q0, Q3. So hence compute delta dash transitions for each input 0 and 1 for these new states. So delta dash Q0 comma Q1 comma 0, that is equal to delta Q0 on 0 union delta Q1 on 0, that is equal to Q0 Q1 union Q2, that is equal to Q0 Q1 Q2. The new state is generated. So here we are getting the new state which is not available already, right? So if the new state is generated, mark it as a new state, and we have to find out the transitions on 0 and 1. And Q0 Q1 on one input symbol, Q0 Q1 take input symbol, that is equal to 1. So see your transitions Q0 Q3 and 5. So we are getting Q0 Q3, but Q0 Q3 is it is not a new state. That state is already there, and we are finding out the transitions on Q0 Q3. So take this Q0 Q3 on 0 input symbol. So we are getting on 0, we are getting Q0 Q1, which is already there, and Q0 Q3 on one input symbol. So now we are getting here Q0 Q3 Q4. This is nothing but a new state which is not already available. So two new states again being get created, right? So find out their transitions. Hence we get the two new states, that is Q0 Q1 Q2 and Q0 Q3 Q4. So find out the transition on each input 0 and 1 for these states. So start finding out delta dash Q0 Q1 Q2 on 0, that is equal to delta Q0 0 delta Q1 0 union delta Q2 0, that is equal to Q0 0. This answer to of transition Q0 0 is nothing but Q0 Q1, but whereas Q1 on 0 go to Q2, Q2 on 0, there is no transition, that's why I mark as a 5. So answer is your Q0 Q1 Q2. You are combining this because it is union operator, that's why Q0 Q1 Q2. It is the same state, it is not a new state. Then delta dash Q0 Q1 Q2 on one input, we are getting here Q0 Q3. This state is already calculated, the transition. Then delta dash take the next state, that is Q0 Q3 Q4 on input 0, Q0 Q3 Q4. So Q0 Q1 union 5, that is equal to Q0 Q1, the not a new state, and on a one input symbol again we are getting here Q0 Q3 Q4, which is also not a new state. The state is already exist, and already we have find out their transitions on 0 and 1 input symbol. So we write here the transition table for the DFA like this. So Q0, so up to this the same thing is repeated here, or same all the rows are copied here. Only the thing is that these are the new transition which we have just calculated. Q0 Q1 on 0 and 1 input, Q0 Q3 on 0 1 input, Q0 Q1 Q2 on input 0 and 1, Q0 Q3 Q4 on input 0 and 1. The transitions we have find it out, and these are the total 8 states or 8 transitions. These are the newly generated transitions. From this transition table, it is easy to draw the transition diagram for the resultant DFA. So the diagram is drawn like this. This is called as the final DFA. This is the final DFA. Q0 starts with 0, Q0 Q1, it will go to Q0 Q1, and on 1 it will go to Q0 Q3. So write it here, right? So and Q0 Q1 on 0 go to Q0 Q1 Q2, Q0 Q1 Q2, whereas on, say for example, Q0 Q3 on 1 go to Q0 Q3. So like this way, or you have to mark all the transitions, right? Now the next point is that Q2 is marked as a final state and Q4 is marked as a final state in the given NFA. So wherever you will find Q2 and Q4, you just make them as a final state. So here Q0 Q1 Q2 is here, so that is the entire state becomes your final state, and Q0 Q3 Q4, the entire state becomes your final state. That's why they are marked as the final states. These are the final states, right? And the remaining transitions means what? So the transitions which are not connected to your DFA, that is Q1 on 0 go to Q2, Q1 on 1 this go to Q1 on 1 go to Q1 on 0 go to Q2, this is the transition, and Q3 on 1 go to Q4. So this is the transition. So it is not connected with our DFA. That's why these are excluded from this resultant DFA. No need to include these transitions because they are not connected. There is no transition from this from any state of the DFA to this state. That's why these can be removed. This cannot be included in the resultant DFA, right? Okay. So that is our final DFA. So the conclusion is also written here as Q1, Q2, Q3 and Q4 are not part of the final DFA. See the statement as Q1, Q2, Q3 and Q4 are not the part of our final DFA. We can exclude these states. So these states, whatever with the Q1, Q2, Q3, Q4 are excluded, and you can rename the state like your capital A, then capital B, C, then D and E. So you can have anyway. So you can have capital A, you can give name B and C here. You can have D and E here. It is depending upon the how you can write the nomenclature. There is it makes no difference. Only the thing is that the transitions must be correct. These transitions from this state only on input symbol 1 go to this state. From this particular state, input symbol 0 go to this state, and input on 1 go to this particular state. Transitions must be correct. Name may be the different one, but the transitions must be correct one. The next example is given here, so we'll just quickly go through it. Step 1, write the first step. As you know that first we have to write down the transition table for the given NFA, and the table is Q0, Q1, Q2, Q3, right, and Q0 and Q1. So Q0 is the start state as well as it is a final state. That's why it is a mark with the start as well as the final state. Q1 is the final state. So how many states are there? There are 1, 2, 3, 4, and new states are Q1, Q2 is another one state, and Q1, Q3 is another second state. So these are the two new states which we observe here from the transition table. So start calculating the delta dash transitions. So from the transition table, we get two new states, that is Q1, Q2 and Q1, Q3. So hence compute delta dash transition for each input 0 and 1 for these new states. So delta dash Q1, Q2, 0 input, delta Q1, 0 union delta Q2, 0, that is equal to Q1, Q2, which is not a new state. Now delta Q1, Q2 on input equal to 1. So we are taking here delta Q1, 1 union Q2, 1. So here we are finding Q1, Q2. Again, it is not a new state. It is a present. It is a state which is already present. Okay. So next, now take the next state. Now compute delta dash transition for state Q1, Q3. Q1, Q3. So delta dash Q1, Q3 on 0 equal to Q1, 0 union Q3 on 0. So it creates you, or it gives you Q1, Q2, which is not a new state. Q1, Q3 on 1. You will find here both the states are phi. There is no transitions from Q1 on 1 as well as Q3 on 1. That's why both the states are phi. So this is the case, and hence the final transition table for the equivalent DFA, it is given as, see the transition table here. First 4 rows are common. Only the transitions which we have calculated for Q1, Q2 and Q1, Q3. So as you know that Q0 and Q1, they are the final states. So wherever there is appearance of Q1 as well as Q0, you mark it as a final state in the resultant DFA. So here is appearance of Q1 and Q1. So this entire state is marked as a final state. So from this transition table, draw the transition diagram. So from this transition table, the transition diagram is being drawn here. So Q0 on 0 go to Q1, Q2. Q1, Q2 on 1 go to Q1, Q3. Whereas Q1, Q3 on 0 go to Q1, Q2. And Q1, Q2 on 0 is nothing but the self transition or the self loop. Now see here, Q1 on 0 go to this particular Q1, Q2. Q3 on 0 go to Q1, Q2. Whereas Q2 on, say for example, Q2 on 1 go to Q1, Q3. But you can remove these states. You can remove these states because these arrow, because you can remove these states because they are not significant states. These are not, one can say there is no path or there is no transition from the start state to this particular q1 q2 q3 states. That's why these states can be removed from your final DFA, and only the states are remaining, that is q0, this one state and this one state. This can be excluded from the resultant DFA. So I can draw like this: A, B and C, with the mark as a, this mark as a, this marked as a B, and this state is marked as a C, and these remaining, these no need to draw this q1 q2 and q3 state. Getting this point? So this is the way. Okay, so one more example, we'll just quickly go through it. Write the transition table for the given NFA. So transition table having q0, q1, q2, q3, q4. The final states are q0 as well as q4. The transitions are given. The only one new state we are observing here, that is nothing but your q0, q2 in the transition table. So find out the transitions. From the transition table, we get two new states, that is q0, q2. Only one new state. So hence compute delta dash transitions for this state q0, q2, the same state we are getting here. And on one transition, on one input symbol, we are getting q1, q4. That is nothing but one new state is generated. So we have to find out the transitions for this newly generated state q1, q4. So see here, now compute the delta dash transitions for each input, 0 and 1 for the new state, that is q1, q4. So by finding out on 0 input, we are getting q3, but q3 it is not a new state, it is already available. And we are getting here q3, q4, but this q3, q4 is not available. The new state is generated. So again, we have to find out the transitions for q3, q4 on 0 input and 1 input. Now q3, q4 on 0, it gives q3 only, which is not a new one, and q3, q4 on input 1, we get here q3 only. So no new state is being generated. So we can now stop here because no new state is being generated. So finally, now no new state is being generated. Hence the transition table for the above delta dash transition for the resultant DFA is written as q0, q1, q2, q3, q4. These are the states already given in the NFA, and the new states are q0, q2, q1, q4, and q4, q3. And the transition which already we have calculated for this, and all the states are written in the square bracket because it is a DFA. And the transition diagram for the resultant DFA, it is drawn like this, right? So q0 on 0 input, it goes to q0, q3, q0 on 1 input goes to q1. So in this way, same way, whatever maybe how many transitions are given in the transition table, the same transitions we will draw in the transition diagram. And this is our resultant DFA. We can say this is our final DFA. It is answer. That is, we are able to convert the NFA into DFA. Result, the NFA given in the problem, we have successfully converted that NFA into deterministic finite automata, that is DFA, right? Okay, so these are the questions for homework. So you can try these questions, convert the following NFA into DFA. So try to solve these questions with the given methodologies or the methods which I have explained during the lecture. So first NFA, second NFA diagram, and this is the third NFA. These are the questions, or we can call it as a homework. Convert the following NFA into DFA. The course outcome, so we have learned in this session, is how to convert, or the conversion of NFA to DFA, or more precisely, conversion of NFA without epsilon moves to deterministic finite automata, that is DFA. Course outcome attainment of the session: to construct finite state machine to solve the problems in computing. And the reference book, always refer the standard reference book only. So thank you. So let us stop here for the today's session.